is David Morejon, and today we'll be doing a titration problem, and it reads as follows. A 75 milliliter solution of hydrogen chloride with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of calcium hydroxide with 0.157 molarity. What was the concentration of HCl in the original solution? Right there, that is what we need to find. We need to find the concentration of HCl, which is the molarity. So what we're gonna do is we're gonna write down what we have for right now, which is 27.3 milliliters of calcium hydroxide and 0.157 molarity of calcium hydroxide. And we also know that we have 75 milliliters of hydrogen chloride. We will use that to write our equation first. So we know we have calcium hydroxide. Sorry about that. Plus hydrogen chloride. And by combination, we can see that hydrogen will combine with hydroxide, making H2O, water, which will be in its liquid form. And then chloride will combine with calcium, making calcium chloride. Sorry about the handwriting, this is my first time. And we can see that the calcium is a +2 ion, so we're going to write 2, and we have 2Cl here, so we have to have 2Cl here. And then we have 2 oxygens on our left with 1 oxygen here, so we have to combine that one as well. And that leaves us with 4 hydrogens on the right, and 4 on the left. So that means we're in an equal equation right now. Okay, now that we have our balanced equation, we're going to start doing some math. Fun. Alright, so first, we can see that for every calcium hydroxide, there is 2 hydrogen chlorides. So from there, we're going to go and try to get the moles of hydrogen chloride, which is and we're going to get the moles, and then using the moles and the given volume, we will use it to find the concentration of HCl. So first, we have to write the moles of calcium hydroxide, which is, to get that, we use the 0.157 molarity that was given, and we multiply it by the volume that was also given, which we will need to convert to liters because that is the only way that we can get the moles. If not, if we don't use liters, then it'll be a wrong answer. So it'll be 0.023 liters of calcium hydroxide, and that will give 0.00428 moles of calcium hydroxide. Oof, that's ugly. Okay. From this moles, we're going to use the conversion factor. Like I said before, for every calcium hydroxide, we have 2 hydrogen chlorides. So we use the given moles here, 0.00428 times 1 calcium hydroxide over here, over 2 hydrogen chlorides. And this will give us the moles of hydrogen chloride, which will be 0.0085722. And now we will use the given volume to find the molarity. Again, we have to make it in liters. So to find molarity, you have to do moles over volume, which will be 0.0085722 0.0085722. Sorry about the writing. Oh my god, that's terrible. Divided by 0.75 liters. Again, remember liters, not milliliters. And this will give us 0.1142 molarity of HCl. That right there is the answer we want. Now, you may ask, how do we know that water was formed? Because if you use this, you can see that right here, we're going to have both our containers, each with its own substance. Right here we have calcium hydroxide. And on the other side, we have hydrogen chloride. And per the equation, we can see that there is 2 hydrogen chlorides, so we write 2. And once they combined, they will combine and make water. It will create, well, before that, we can see that each of these are alkali metals or they are dissolvable in water. So it will create, HCl will break down into hydrogen ions and chloride ions because it is a strong acid. And calcium hydroxide will also do the same because it's a strong base. And that will make, so before all of them combine, all the ions will be floating around. After that, they will combine and create water. And there's 2 hydrogen oxides right there. This will lead to the combination of hydrogen and hydroxide, making H2O. Well, 2 H2Os, because there's 2. 2 H2O. And combining, you can say it also makes, like on the equation it says, calcium chloride, but they're a spectator ion, so we don't really write it, but you can continue to write them here. Calcium 2 plus, and then the 2Cl. There will be spectator ions just floating around, not doing anything. And this is the equation, or a graph, better said, a visual of how it can be made. So that's how you get the answer, or that's a visual to represent how to get the answer. Some people may have some problems getting to this answer because one thing they didn't do is they didn't get the moles. They instead used molarities, didn't convert to moles, and instead plugged the molarity. Let me change colors. They plugged the molarity here instead of putting the moles, and that gave them a wrong answer from the start. As well, if you don't change the milliliters to liters, you will not get the right answer because molarity is equal to moles over liters, not milliliters. To make it milliliters, you would have to do much more work, and you don't want to do that. You want to go the easy way. As well as reading the equation wrong. If you don't write the equation wrong, you will not get this. This is very important. Let's say you instead write 4 HCl's for every calcium hydroxide. It will give you a completely different answer, so you have to watch out and make sure you get the right equation. Again, this is the best thing to learn is by visuals. Remembering them will be the best thing to help you out during the test. Thank you and have a good day.